Today I would like to discuss that age-old question, does Santa exist? Presenting two perspectives from a scientific standpoint. First of all, we will look at the Newtonian perspective of Santa Claus. Now, in the world, there are approximately 2.5 billion children according to recent census estimates. 33% of these households are Christian, which means there are 825 million Christian children in the world, since Santa does not appear to handle Hindus, Jews, Muslims, Sikhs, etc. Well, assuming there are 2.5 children per home, that means there are 330 million homes that Santa must visit on Christmas. We will assume there is one good child in each, which might be a bit of a... So, how long does Santa have to work with? Well, we're going to assume he travels east to west, which should give him a little bit extra time due to the rotation of the Earth, 31 hours instead of 24. Well, 31 hours in 330 million homes means he has to visit approximately 3,000 homes each second. So each home he has 0.000333 seconds to drop off presents, drink milk, eat cookies, etc., get down the chimney, get back up the chimney, get in the sleigh, and head on to that next home. That means the sleigh must be amazingly fast. So, let's assume these houses are evenly distributed across the globe, even though we know it's not true, it's a good approximation. That means the average separation of each home is 0.78 miles, about 3/4 of a mile. So 0.78 miles per house times 230 million houses means he must travel 258 million miles in those 31 hours. Doing this gives an average speed of 2,300 miles per second, which works out to Mach 11,000 for his sleigh. A normal reindeer can run approximately 15 miles an hour. That's one fast sleigh Santa has tricked out. So how much does this sleigh weigh? Well, let's assume each child gets only a medium-sized Lego sled weighing approximately 2 pounds. How many reindeer would it take to pull his sleigh? Well, assuming a super reindeer can pull 1,000 times as much as a normal reindeer, he would still need 36,000 reindeer to pull his sleigh. So the weight of his sleigh, plus the presents, plus 36,000 reindeer, plus the fat Santa, equals 879,000 tons. The Santa will experience great g-forces in his journey as well. He must go from rest to 2,300 miles per second in 1/6000th of a second every time he starts and stops. This yields a g-force of 2.2 billion times the force of gravity. Your average human can survive approximately a 30 g impact. A force on a 250-pound Santa, which seems ridiculously light, would be 550, oh my god, I have to count those zeros, 550 billion pounds. What about air resistance? Well, as Santa goes through the air resistance generates 3.2 quintillion watts on the lead reindeer. For comparison, that's over 900,000 times the power the entire United States uses, according to 2004, the most recent year for which figures were available. Reindeer would be vaporized in 0.00426 seconds. That's for the entire team. Therefore, Santa is dead if he ever delivered presents. But wait, there's a potential loophole. In the 20th century, we discovered quantum mechanics. You might recall from your high school chemistry classes that things behave very strangely when we look at small objects like protons and electrons. And this could potentially provide a way for Santa to do his work. The physics of an electron, you might remember, they exist as probability fields when no one is observing them. They are not single objects. There's a probability they could be at any given place. Therefore, the electron can be seen as being in 2 or more places at once as long as no one is observing it. When an electron is measured, its wave function collapses and we observe it in a single location, the single location being determined by its probability function. So what if Santa was a macroscopic quantum object? Well, Santa would behave like this electron. He can visit everyone in the world at once as long as no one observes him. We have evidence for this in the fact that children are told to go to bed so they don't see Santa at night doing his job. As long as they don't see him, Santa can be everywhere in the world at once and do his work rather leisurely. There's a lot of Santas. What happens if someone does happen to observe Santa? Sometimes kids do stay up late at night trying to catch Santa. Well, then his wave function collapses, and he is observed to be your dad in a Santa costume. Well, that begs the question, do these macroscopic quantum objects exist? Maybe. Physicists have made multiple particles behave as one macroscopic quantum particle, but none are as large as Santa yet. However, just because we've not succeeded in making one that large, they cannot be ruled out. And we should also note that it is easier to create macroscopic quantum objects at extremely cold temperatures. Santa lives at the North Pole. I do not think that is a coincidence. So the existence of Santa cannot be ruled out as long as we appeal to the laws of quantum physics. So, I want you to have yourself a quantum little Christmas.